Hello, everyone, and a very warm welcome to all of you. I'm Dr. Alison Every. I'm the Director of STEM Careers here at the Australian Academy of Technological Sciences and Engineering, or more fondly known as ATSE. So I'd like to begin today by acknowledging the traditional owners of the lands that I'm joining you from today, which is the lands of the Ngunnawal people, and pay my respects to their elders past and present. And I'd also like to extend that respect to any Aboriginal or Torres Strait Islander people joining us today, as well as to acknowledge the traditional owners of each country that you are joining from today. And as we come together today to share and discuss our knowledge and experience, we recognise the traditional knowledge and deep history of Australia's First Peoples as the world's oldest surviving culture and Australia's first scientists and technologists. So before we get on to today's webinar, I just want to start with a little bit of housekeeping. So we would like to remind all attendees that they have agreed to abide by ATSE's Code of Conduct, including as you enter your questions into the Q&A channel. This webinar will be recorded and the recording will be made available on ATSE's YouTube channel shortly after today's session. And excitingly, you can now also listen to this and other Shape Your Future episodes on our podcast. So to do that, just search for STELR Shape Your Future wherever you get your podcasts, and don't miss out on a chance to listen to our audio-only interview from high school students with the ATSE President and Australia's former Chief Scientist, Dr. Kathy Foley. So captions are enabled today, so if you require them, they should pop up at the bottom of your screen. Be sure to submit your questions in the Q&A box at the bottom of the screen at any point throughout the webinar. So before I hand over to today's moderator and our brilliant panelists, I'll just share a very short story about me and my career journey. So I started out after finishing secondary school to undertake a Bachelor of Biomedical Science at Monash University, which I really loved. And that really sparked an interest for me in biomedical research. So I went on to do a PhD at WEHI, also known as the Walter and Eliza Hall Institute in Melbourne. After completing that PhD, which was on trying to develop vaccines to prevent type 1 diabetes, I went on to work for about 12 years at Melbourne University, undertaking more research on vaccine development and also understanding the inflammatory mechanisms that kind of kick in when you have an infection, particularly in the stomach. And I looked at a particular bacteria called Helicobacter pylori. So I really loved that. But after a while, I thought about what impact I can have. And I realized that I really loved supporting other people to access opportunities in STEM education and in STEM careers. So that led me to working more on programs to support people to access those opportunities, either through mentoring, through scholarships, through STELR, through Shape Your Future. So Graham, so my team delivers the STELR program that you're hopefully all very familiar with, as well as scholarship programs and mentoring program. And that's a really rewarding way to engage with STEM in a different way and use those skills in a different way. So just to finish up before I hand over to the panelists today, this webinar series is brought to you by ATSE's National STEM Education Initiative, STELR, which is designed to engage young people in rich STEM learning at school by using hands-on curriculum-aligned resources to explore the principles of sustainability and renewable energy. You can find out more about the program by visiting stellar.org.au. So today's session aligns with World Health Day, happening next Tuesday on the 7th of April. The theme this year is Together for Health, Stand with Science. And it's an opportunity for us to recognise the importance of scientific collaboration to protect the health of people, animals, plants, and the planet, and to highlight evidence-based action for a healthier future. For the students in your room, you're at the time where you're making big decisions about your future. So we'll hope you'll stay with ATSE throughout your career, whether it's participating in one of our scholarship programs that I mentioned earlier, using our resources, or maybe even one day becoming a fellow. So let's get started with our first speaker, and that's one of ATSE's fellows. And he is a world-leading medicinal chemist and an ATSE fellow. His name is Professor Michael Cassiu. So Michael is a world-leading medicinal chemist with expertise in drug discovery. His innovative approach combines chemistry and molecular design. His innovations have been commercialized in several companies, most notably notably Procardia Therapeutics, which are producing entirely new medicines for cardiovascular disease, and Canoxus Therapeutics, who are targeting mental health conditions, including substance use disorders. So he holds more than 20 patents, several of which have been licensed to pharmaceutical companies. And Michael leads the Centre for Drug Discovery Innovation and the New South Wales Organoid Innovation Centre, a multi-institution facility applying cutting-edge stem cell techniques to accelerate drug discovery and design. He is also a node leader of MedChem Australia, a national initiative aiming to bridge the gap between research and commercialisation. So Michael's remarkable achievements have been recognised with the Eureka Prize for Leadership in Science and Innovation in 2023 and the Australian Financial Review Higher Education Award for Research Commercialisation in 2024. That's quite the bio. So Michael, thank you so much for joining us today, and I'll hand over to you.
Thank you, Alison, and welcome to all the students, educators, and other members of the community joining us today. Let me start by acknowledging the traditional owners of the lands in which we meet, and for me, that's the Gadigal people of the Eora Nation, and pay my respects to their elders past, present, and emerging, and acknowledge their traditional custodianship of country. It's great to be here today talking about such an important topic as part of the World Health Day. Health science is how we discover new treatments, understand complex diseases, and develop new ways of helping people live healthy lives. It includes disciplines such as biotechnology, biomedical engineering, public health, data science, and medicine, all contributing to our understanding of how people live. As the world faces challenges like emerging diseases, aging populations, and health inequities, skilled professionals drive innovation and deliver solutions that improve well-being locally and globally. I'm very excited to be here with our other panelists, Associate Professor Nusin Nasiri and Alicia Kitchenskar, to explore just that. But before we hear from our panelists, first I'd like to tell you very briefly a little bit about my own work and my career path. So let me start with my high school years, which is actually not on the slide. So when I was in high school, like most kids, I really did not know what I wanted to do, but really found a love for chemistry. I just enjoyed it. I understood it so well, and I knew that all I wanted to do was chemistry. I didn't know what the outcome in terms of career would be or anything like that. I just liked chemistry, and I went to university to do a Bachelor of Science degree to do chemistry. And I graduated with an honours degree in many years ago, and then stayed on because I enjoyed what I did and completed a PhD at the University of New South Wales. So before I go through my whole journey, I think it's really important to find something that you enjoy and just follow that. And for me, it was STEM, it was chemistry and biology. Once I finished my PhD, again, I was one of those people that didn't know what I wanted to do as a career other than continue that path of science, innovation, and research. But what I did fall in love with was understanding problems, how we can use STEM to understand problems that the world faces and try to derive solutions. So I went from a research kind of career education and through a PhD into the early research which I did, which was my first paid position, which was at the Australian Nuclear Science and Technology Organisation, where the focus was developing radio-labeled molecules to be able to study the living body and in particular the living brain. So it had an applied use of the chemistry that I trained for years to kind of master. So I went from that to an applied problem because we then not just developing science or discovering science for the interest of science, but actually using the power of science to understand real life problems and trying to solve them. As part of that position, I also experienced the time in France at the CEA in France to expand that learning, which I didn't learn at the University of New South Wales, but went overseas to gain that kind of experience. How do you actually develop molecules to study the living brain in living patients? I did that in 1993 and continued that through fellowships at the National Institutes of Health, as well as spending some time at the Johns Hopkins University in the USA. So I went from education to research to actual fellowships that expand my career in STEM. I then came back to Australia in 1996 and took up a position at the Royal Prince Alfred Hospital in Sydney in the Pet and Nuclear Medicine Department. Stayed there for 10 years developing molecules for patient care. So again, the principle of using science, particularly STEM-based science, in my case, it was chemistry, to actually use that to develop molecules that help us solve real life problems. I then transitioned from the health system back into the university, where I was a professor of medicinal chemistry, and tried to expand my learning of STEM, not just from a therapeutic, from a diagnostic perspective in terms of the use of chemistry, but also to be able to develop therapies to actually treat disease. And then now I'm still at the University of Sydney as the director of the Centre for Drug Discovery Innovation. So there's a lot in all of that. My message to everybody is follow what you enjoy doing. And I find that STEM is really the foundational sciences that help you understand and solve biological problems that are particularly health for me, which is, one of not just national burden, but is a global burden. So an education and a career in STEM has been tremendously rewarding. I would not change a thing, and I would encourage everybody to kind of follow your passion and follow your dream. The important message from me is it's okay if you don't know what you want to do as a long-term career. I never did, but what I did was follow what I enjoyed doing, which was chemistry. I fell in love with chemistry at a very young age and just followed that through. And what this shows you in terms of my journey and my career, it opens up a multitude of doors for you, a multitude of opportunities to actually do things that are not just important to yourself, but important to humanity and mankind. So, uh, with that, I would like to pass on or introduce our one of our panel members, and I'm delighted to introduce our next speaker, which is Associate Professor Nushin Nasari. Professor Nushin Nasari is a materials scientist and engineer at Macquarie University, where she leads the nanotech laboratory. She develops smart nanomaterials and nanosensors to improve health diagnostics, environmental monitoring, and sustainable technologies, translating cutting-edge research into real-world impact. Her work has been recognized with major national awards, including the 2025 Eureka Prize for Innovative Use of Technology, the 2025 Engineers Australia Professional Engineer of the Year Award, and the 2025 David and Valerie Solomon Award from the Australian Academy of Sciences and Engineering, ATSE. She's an ARC Industry Fellow and serves as Global Chair of the IEEE Women in Nanotechnology, supporting leadership and equity in STEM worldwide. She's also a three-time TEDx speaker, passionate about inspiring young people to pursue careers in STEM. Nushin, thank you for joining us today.
Thank you so much, Michael, for wonderful introduction. It's my honor to be here. Thanks for the invitation. I would also like to acknowledge the traditional custodians of the Macquarie University land, the Wotjomoto clan of the Daro Nation, whose cultures and customs have nurtured and continue to nurture this land since dream time. I pay my respects to elders past, present, and the future. I'm a materials engineer who is working in the field of health and medical sciences. So a little bit of a background about me. I'm from Iran. And if you don't know where Iran is, this is where it is on the map. It's a beautiful country. We might not experiencing very good days currently, but it's a beautiful country. The landscape is wonderful. I grew up in a very small town next to the Caspian Sea. If you go up the hills in my hometown, this is the view that you're going to get. My dad is a farmer. I didn't grow up on the farm, but it was pretty close to where we live. It was very close to the farm. So this is me. when I was, I don't know how old I was back then, but this is my dad's farm. And in terms of my childhood, it was very well connected to nature. We have 4 seasons in where I live. So you get snow on the mountains, you get all these green landscapes during the springtime. You have all these waterfalls from the mountains. So it's impossible to ignore the nature when you grow up in such an environment. And I think nature had a very important maybe play a very hidden factor in my career, because there's a lot of mystery and there's a lot of discovery in nature. So I grew up there until I was 18-year old. So the town is very small. We did not have any university in the town. So in order to go to the university and get the best education, I had to go to Tehran. Tehran, as you can see in this image, is a capital city in Iran. It's a city of 15 million people during the day, and then 9 million during the night, because people come from the very small cities around the Tehran to go and work. That was a very significant challenge for me, a kind of like a turning point in my life. Struggle a little bit. I'm a country girl, grew up on a farm, and now suddenly I have to find my way in a city of 15 million people. So I studied at University of Tehran, which was the top university back then. Did my bachelor and master at University of Tehran as a material science and engineering. Then I finished my undergrad, my coursework studies, bachelor, master. I worked for a short time in a couple of companies, and I realized that I love research and science and university environment. So I decided to now challenge myself again and then go overseas and study in an international university. So I came to Australia around 14 years ago, studied engineering, materials engineering, but PhD in a focus in nanomaterials at the Australian National University. I graduated from Nanotechnology Research Laboratory, and then I moved to Sydney to work as a researcher. We call it postdoc, which means that you work in a university as a researcher after you finish your PhD. Is a postdoctoral. So I actually went to University of Technology, Sydney, and there was an institute named Institute for Biomedical Materials and Devices. I worked there for a bit shorter than 2 years, and then I moved to Macquarie University as an academic. So I started as a lecturer, and then I stayed at Macquarie University all the way in my entire academic career, lecturer, senior lecturer, associate professor, and just very recently being promoted to the professorship. I established my own nanotech laboratory here. I now have my own team. We do a lot of different types of nanomaterials fabrication. And then we work on a wide range of devices. These are some of the examples of the devices which is relevant to the webinar today, which is health. We're not limited to health. We do work on devices that has an application in farming, very close to my heart, in agriculture, in environment. But in terms of medical devices, I just put some examples here because most of the time people have this, I would say, misunderstanding that if you want to work in medical devices or in medical field, you have to become a medical doctor. I'm an engineer, and I'm still working in the field of medical devices because literally everything that the medical doctors use has been designed by an engineer. So we always take the credit as an engineer in any field. But let me give you a couple of examples. Like, it might seem science fiction to you right now, but believe me, many of the devices we use right now, 10 years ago, they were science fiction. But let me give you examples so you can have in future, very, very near future, you're going to have smart contact lenses that you're going to wear, and then there's a tiny sensor embedded in the contact lens which can analyze your teeth and then give you an information about like a chemistry, as Michael said, what chemistry, how your teeth chemistry might change based on different condition. Similar concept can be applied for like sweat analysis. You're going to have a patch like a tattoo or like a sticker, analyze your sweat, or you can have a mouth guard that you can vary, let's say 10 minutes per day, and it has a sensor and you can see this photo, and then you can analyze your saliva. Some of the other works that we do is that at the bottom left, you can see that there is a UV sensor. When I came to this country, and that's what I've done my PhD on, I've been told that we have the highest incident and mortality rate of melanoma, and 94% of the melanoma is actually because of the overexposure to UV. So we started developing a sensor that can measure the UV index and talk to the end user and tell them how long they've been exposed to what level of UV. And this is for preventing skin cancer, still quite relevant to medical. And last example I give you is the breath analysis, the way that we can do blood tests to pick up the biomarker in human blood in future. We're going to have breath analysis. You're going to breathe into a bunch of sensors, which is shown in this image, and these sensors can pick up different biomarkers in your breath and tells you about what is kind of happening in your body. And the last things, who inspired me to come to STEM, I will give the credit to my dad. Yes, he's a farmer, but he is a scientist in mind. He has a degree in engineering, and he actually look at everything as a discovery. And from a very, very young age, he kind of encouraged me to think about everything from a science perspective, from an engineering perspective, from a problem solver perspective. So I'm very lucky because I think he see that the curiosity sits in me. And since then, I could never stop being excited about science and discovery.
Thank you, Nushin. It is now my pleasure now to introduce our final panelist, Alicia Kitchenskar. Alicia is a PhD candidate in medical physics at the University of Sydney, researching technology to improve the accuracy of cancer radiotherapy treatment. Her work spans software development, experiments with radiotherapy machines, and clinical data analysis, all aimed at tracking tumor movement in real time so radiation can be delivered more precisely. Alicia has also presented her work at national and international conferences and collaborates with clinical and academic researchers. Outside of her research, Alicia is passionate about creating opportunities for the next generation of STEM students. Alicia, welcome.
Thank you very much, and I'm grateful for the opportunity to speak today at the webinar. Before I begin, I'd also like to acknowledge that where the lands on which I'm joining this webinar from today, which is the land of the Wango clan from the Eora Nation, and I would like to pay my respects to elders past, present, and emerging, and extend this respect to all Aboriginal people who are here today. So I've been asked to share a little bit about my career journey from studying science in high school to my current role as a third-year PhD student in medical physics. I'm sharing my journey so that you can learn a little bit more about what a medical physics researcher does, and just in case any of you are considering studying science at university or pursuing a research career. There's just as many career pathways and stories as there are researchers, so my story is just one of them, but I hope my talk can be useful for you. So when I was taking my year 11 and year 12 high school classes, I had no idea where it would take me, but I knew that I really enjoyed studying science, especially physics. I had a really good physics teacher who made the subject feel interesting. He had a way of asking questions that made you actually think about what we were learning. And I remember particularly enjoying learning about mechanics and electromagnetic radiation, which are both quite relevant to the work now I do as a PhD student. After completing the HSC, I enrolled in a Bachelor of Science at the University of Sydney. So while I liked physics in high school, I didn't actually expect to become a physicist, but I found that I really enjoyed learning physics and biology as well as applied maths, and I ended up majoring in physics. The first photo on my slide you can see is actually a photo of the physics building on the University of Sydney campus with some jacaranda trees which come into bloom every spring. So that was the start of my career journey, but I didn't actually know what I wanted to do after the degree. However, I got the opportunity to do a research project and complete an honors year, and I decided to complete this at a medical physics research group. I hadn't heard of medical physics before I started university, but I found that it was a field that's focused on applying physical principles. methods and techniques to prevent, diagnose, and treat diseases, particularly cancers. And one major subfield of medical physics involves studying and advancing technology for radiotherapy, which is a cancer treatment that uses precisely targeted high energy rays or particles to damage DNA within cancer cells. In this way, we can destroy the cancer cells or stop them from growing. And there's a photo of a radiotherapy treatment room in the middle of my slide. So the big machine in the center of the room is the linear accelerator, which is what delivers the radiation. I really enjoyed my honors project and had good supervisors, so I ended up completing a master's degree in medical physics a couple of years ago, and this is a requirement for working in a hospital as a clinical medical physicist in the radiotherapy department. But I really found that I enjoyed doing research, so I actually started, pivoted a little bit, and I started my PhD project with the same master's supervisors at the Image X Institute at the University of Sydney. So that's my current work, which is focused on improving the precision and safety of radiotherapy. We know that cancer treatment uses radiation, which has to hit a tumor precisely. But what people don't often think about is that the tumor actually moves when you breathe or like when you're digesting or any other kind of physiological process. So my job is to figure out how to track that movement in real time so that the radiation beam and the treatment can stay on target. So far, my PhD has involved a lot of software development, coding up a real-time motion management software, some experiments in the radiotherapy clinic using motion platforms, and collaborations with medical physicists and software engineers. I've included a photo of one of my experiments, and we actually completed another one yesterday. So when I started studying science, I had a bit of an idea that scientists might be kind of really bright minds that kind of do their work in like isolated offices. But modern science is actually quite collaborative. And as a researcher, you're one part of the research ecosystem and work with colleagues and other collaborators. So for me as a PhD student, the research group that I've joined and the supervisors I work with, they largely determine the topic that I'm studying. But it's always up to the individual students to do the science and learn and develop as researchers under their instructions. So I put some photos of my research group first in the lab and then also when we were attending a conference, and including some of my PhD supervisors, Professor Paul Keel and Dr. Chandrima Sengupta on the left and the right on the first image. Some other opportunities I've had as a PhD student due to my research, they include attending conferences and also publishing papers, which I'm slowly starting to do now that I'm in my third year. I've also been fortunate to apply to and receive some scholarships to support my research, and it's given me an insight into the grant writing aspect of being a scientist that postdoctoral researchers after the PhD experience once they've graduated from the PhD. And another main thing I'm passionate about is educating and providing opportunities for other students interested in research and STEM careers. So I've been involved in organizing some students' conferences and panel events and careers workshops for other university students in STEM. So I'd like to, encourage all students who are interested in STEM to participate in events like these, such as this event, the Shape Your Future webinar series. I'm conscious of time, but just before I finish, I'd just like to talk about that being a university student or a PhD student is not always easy. For me, it took me a little bit of time to adjust to the university workload and the very independent style of learning after high school. But what was important for me was finding and reaching out to the right supports and then trying and learning the different study strategies. And even as a PhD student and researcher, I've got some moments of setbacks in my research, but this is always just part of the process and everyone experiences them. For example, back to my experiments, some of my experiments didn't work for a couple months and we had to go back and redo them. But this is just what a PhD research involves, and these challenges help shape my problem-solving skills, physics knowledge, and also resilience. So the last thing I want to share that these skills are the very skills you're building now and in the future, in any future studies, problem-solving, scientific and mathematical knowledge, and the ability to think carefully about evidence. And these are just exactly what research is. So you don't have to know what you want to do yet, and curiosity is just enough to start. Thank you.
Thanks, Alicia. I'd love to bring back both Nushin and Alicia so we can start looking at what's coming through. There are some questions coming through the Q&A, and please keep them coming through because we've got time to answer them. And if any questions that we don't get to answer, they will be answered and be sent to you. So please keep your questions coming. But before I go to the Q&A, let me start by asking both of you, and I know you're at kind of different levels of your, or different stages, not different levels, different stages of your career. The question, an interesting question to pose to both of you, and maybe you can start first, Nushin, is what career advice, knowing what you know now, what career advice would you give your younger self?
Um, yeah, I think I'm gonna give them the same advice you said in your talk, Michael. Um, Better to follow your heart. It's very important because I love what I am doing. And as Alicia said, it's not always easy. You're going to have difficult days. No matter if you work at university or if you work outside, there's going to be some challenging days. And I think the, the, the the biggest motivation that keeps me going in those challenging days is I love what I do. Otherwise, you might get exhausted way sooner than what you think, and then you might. Uh, I think let me put it this way. I think the biggest luxury that you could have is to do what you love and you still get paid for it. I think um, that is a luxury, and the all the attendees, you are at the stage in your career and your life that you can make this happen by following your heart, and you do what you love to do, no matter if they pay you or not. And then the cherry on the top is that you get paid for that. So I think that's a wonderful feeling. So that's my advice. And don't be scared of changing it because you might love different things in your career. If let's say 10 years ahead you realize that you don't enjoy doing this anymore, be very honest with you. Do not push yourself to stick with it because you've told your high school friend that you love to, for example, become an engineer. You become an engineer and then 10 years later you realize that now you wanted to do something else. Do not force yourself to stay with where you are just because um, that was your identity and you identified yourself as someone who loves engineer. You have to reinvent yourself over and over and over in life, and that's the beauty of that. So don't be scared, keep changing your direction as long as that direction is very close to what you have in your heart.
Yeah, wonderful. Thanks, Nushin. Alicia.
Yes, I also agree with what Michael and Roshan were talking about following your passions. I don't think I would be able to be so focused on my research or just my work if I wasn't really interested in just the science behind what I'm doing. I think some other things I probably would like to tell my past self, don't be scared of challenging yourself. Like if there's an opportunity that you hear about and then you think, oh, it would be really cool if I do this, like maybe take on this research project or like apply for this scholarship or something, just do it and then just challenge yourself and you might be pleasantly surprised with how far with what you can achieve. And then just the other thing, surround yourself with good people. So I would try to get to know your peers and also any mentors that can help you or like supervisors, people who can like champion your work or like support you on your path. I think that's always really helpful.
Yeah, wonderful advice. It'd be remiss of me to not give my perspective as well, in terms of what I would give myself, what advice I would give myself. Um, and it's exactly what both of you have mentioned. It's actually being brave and courageous with what you choose. Make sure you follow what you enjoy. If you follow what you enjoy, you will always succeed and be brave. And I think STEM offers exactly that opportunity. For me, it was kind of natural, as I said, when I was going through my career. I really didn't know what I wanted to do or whether I was going to become an academic. It wasn't part of my plan. I just wanted to do research in chemistry. That was what I enjoyed doing. And it's probably not that surprising, although I probably didn't recognize that at the beginning, at the very beginning of my career, coming from a Greek family, from a big Greek background, family is always important. Making sure that you're looking after your family and part of the extended family. So therefore, getting into STEM and particularly chemistry in terms of trying to develop therapies that actually treat people and make differences, not just to yourself but to others, it's kind of a cultural thing. So although at the time it wasn't clear to me, there was something innate in the way I was brought up that kind of drove my passion, and I ended up where I ended up. At the end of the day, STEM is a wonderful starting point for making fundamental and impactful discoveries. And if you think, and the impact they have is beyond STEM. So if you kind of think of X-rays, for the discovery of X-rays, which is a physics discovery. The biggest impact of the discovery of X-rays is, in fact, in medicine. And so the profound effect STEM has on, I'd say, the world and humanity is enormous. But the advice here is really find what you enjoy, what you love doing, and do it, and it will lead you to really good things if you apply yourself and if you're brave. But as everyone said, it's about surrounding yourself with the right people. Put yourself in the right environment to be able to make contributions to the world and satisfy your well-being as well. There are some questions in the Q&A, and we'll go through them. The first one from Caroline was, did you learn French when you were in France? I suspect that was for me. Yes, I did, not very well, but I did enjoy the French cuisine while I was there. So that was really nice and a really nice experience. And again, STEM gives you that opportunity to travel the world and participate in these type of activities on an international level. So very, very rewarding. This one's for Nisheen. What would you need to study in school to be able to work on the cool technology you are working in?
So I studied physics and math back in my home country. At the high school, at the second year of high school, you have to choose your major. You can change it at the third year, but it might be a bit challenging. But you can decide biological sciences, linguistics, art, or math and physics. I decided biological sciences first, but the first 2 or 3 months, I realized that that's not for me because I had to. Anyway, I'm not going to go into the details of that, but that is not my personality. I realized that I had to learn a lot of things about, and there were some bloods on the table. There's going to be a lot of blood, and then animals, and doing some kind of experiment and surgery on animals. And I love animals. I can't handle that. So I decided to do math and physics. So why I'm telling you this story, because I can't tell you I loved math and physics. That's why I decided. No, I didn't. I fell in love with it later, with physics more, less math. Math was never my top favorite topic. So math and physics in high school. And then in Iran, we have to do an entry exam to the university. So all the math and physics graduates of the high school in that year, they go to the country exam and they sit at the exam at the same time, and they do like a 3.5 hours of entry to university exam. So you're competing with everyone else who finished math and physics, and then you cannot apply for a medical or art or a linguistic degree at the university. You can apply for either engineering or science at the university. So I actually chose engineering. But yeah, so I mean, I just wanted to say the story about the X-ray is the physics discovery. But then, if you look at the X-ray machine that you use in any hospital that you go, is an engineering-based machine. As I said, we always take the credit. Okay, so any equipment that you use anywhere, all the way from construction to medical to farming to agriculture to like whatever you use is actually an engineering engineer has designed and built it. So these cool technologies that you're referring to, you can be a scientist and work on these cool technologies. I do have so many scientists in my team. I have chemists in my team. I have electronic in my team, and I also have a pharmacist in my team. So it's not a one discipline; it's a combination of different disciplines. Long story short, you can come to the same field from different angles. So you don't need to choose only engineering in order to work on this cool stuff. There is multiple opportunities.
Yeah, wonderful. And I think that's an important message. Lots of things are done in a multidisciplinary nature. The important aspect to a lot of these things, they are grounded in STEM. STEM is really core and fundamental to lots of
Absolutely.
things that we do. Another question for the panel as a whole. Are there better universities to study at for health sciences, or is it better to work at a few of them? So I guess the question is, does the university you attend make a difference to your career? Are there better opportunities or better standards at different universities?
I might
Alicia.
give I might give my perspective. Having recently studied, I only really have experience at the University of Sydney, but I'm from my understanding, the university you go to isn't the main factor in what you end up doing or like how well you do. It's more about like I guess some universities have more of like a focus on certain areas, like at the PhD level that there might be some research groups that are more focused on particular aspects, but like a lot of the Australian universities are really great. So that's not going to stop you if you go to a less like popular university. It's not going to stop you from getting into like a medical career. There's lots of opportunities, and yeah, it's more about the work you do and the skills you develop in those situations, is my perspective.
So the limitation is really your own imagination rather than the physical presence of the university at which you attend.
Yeah, there's great lecturers and great teachers in all the universities. I don't think that's the problem.
Yeah. Nushin, did you want to add anything to that?
I will be a better person to answer this because I never study medical. I do work on devices which have medical applications, but I'm not a medical person.
Yep. So in terms of the different universities offer different degrees, and I think what you need to do is align yourself with a degree because they're not all exactly the same. Is align yourself with a degree that best suits your interest and your passion. And as Alicia said, the universities aren't always. I mean, that's the stepping stone and the start, but it's not the end of a career. It's the beginning, and so it's what you do after that that's critically important. So yep. Another question from the students. What sort of studies do you undertake in university to get a medical career?
I might give that a go. I actually I haven't really studied medicine specifically. However, there's lots of work like in science and engineering that's kind of like adjacent to medicine. Like the medical physics work I do is just like you can work in a hospital as a medical physicist, but it's more about like studying and developing the technology um for radiotherapy treatments, kind of like yeah, doing all the engineering. But for medicine specifically, there's like very set pathways, I think. Like maybe talk to your teachers or other people who know more about the current standards, like the current process. Um, but yeah, there's like Nushin was saying earlier, there's a lot of ways you can work towards like human health, not necessarily just as a doctor.
This question's for all of us. How were your grades in year nine? And I'll go first. Not good.
Me, not my entire high school, but I want to be honest because you asked for year nine. Year nine was good, but year 11 and year 12, especially year 12, my year 12 was the worst grade I had in my entire high school. Yep.
Yeah, I was similar. I think for some reason in year 9 and 10 I was doing really well, but I got a bit stressed out in year 11 and 12, so my grades dropped a little bit. But it's definitely not the end of the world if your grades are a little bit lower, as long as you're focused and there's always pathways to get to where you want to be.
So,
Yeah. Yeah, and I'm a good example of that. I think at year nine, I was interested in lots of other things as opposed to a career in STEM and so forth. So discovering yourself is absolutely fine when you're a younger person. Well, I'm afraid that's all the time we've got for today, and we'll try and answer the questions that we haven't got to online and provide those answers. So I'd like to once again thank Nasheen and Alicia for joining me today and sharing their amazing stories. And thank you all for your thank you all in our audience for joining us. I do hope this session today has left you with a little more inspiration about potential careers in health sciences and in STEM. So with that, back to you, Alison.
Thank you, Michael, and thank you for sharing your amazing story, and also to Nasheen and Alicia for joining us live to the live audience in classrooms and offices around Australia. Thank you for joining us as well. We hope you took something away from today's session and can see how important it is for us to work together to heal the world, even if the engineers all take all the credit. Please join us for the next Shape Your Future on the 5th of May, where we will be exploring careers in telecommunications, from satellites to smartphones, for a better connected world. So thanks once again for joining us, and we'll see you next time. Bye.